Good morning everyone. Welcome to all four e-learning classes. Today we are going to discuss the pancreas. The session number 10. Session number 10 Zoology under Chemical Coordination and Control. The topic is pancreas and its disorder. In the previous session we have discussed the pancreas. Pancreas is a mixed gland of both duct and ductless. That is, it is both exocrine and endocrine. It is located at the loop of the duodenum, and the endocrine part is treated to be the islets of Langerhans. That is, in between the acini there present the endocrine part, which is referred to as islets of Langerhans. It is just only 2 portions, that is 2%. It is, there are 2% of the part of the pancreas is endocrine, which includes the islets of Langerhans. These islets of Langerhans are of containing the cells alpha, beta, delta and F cells. Alpha cells secretes glucagon. Glucagon is the hyperglycemic, as it increases the glucose level by converting the glycogen into glucose. The target cells of the glucagon is the liver, where the glycogen is converted into glucose and increases the glucose level. So it is the hyperglycemic. Whereas the beta cells secretes the insulin. Insulin is a hypoglycemic. The target cells are liver itself, where the glucose is converted into glycogen. So it is hypoglycemic. The third one we discussed is the delta cells. The delta cells secretes the somatostatin. Somatostatin is secreting other 2 sources also we have discussed. That is, not only the delta cells of the pancreas, but also the case with the stomach and intestine. That is, the endocrine cells. Under that we discussed the argintin cells secreting the somatostatin, and also in hypothalamus also the somatostatin, or else the growth hormone, inhibitory hormone we refer. So there are 3 sources for somatostatin. It is considered to be inhibiting the secretion of glucagon and insulin, that is pancreatic hormone. The fourth one is the F cells secreting the pancreatic polypeptide. Pancreatic polypeptide is secreting pancreatic polypeptide hormone from F cells. Is the hormone which is considered to be regulating the secretion of pancreatic juice from the pancreas. So altogether, alpha, beta, delta and F cells, these 2 are what influencing the glucose levels, whereas delta and F cells are recently the studies going on abundantly, more related to that of the delta cells and the F cells. The studies of the delta and F cells is going on nowadays, and it is considered to be regulating the secretions of delta, the glucagon and insulin, whereas F cells pancreatic juice. Now, the deficiency of the pancreas results in the disorders. Now we'll go for the disorders. the disorders of the pancreatic gland results in, first of all, the insulin deficiency results in a diabetes mellitus. Diabetes mellitus is the also considered to be the hyperglycemia. It is referred to be hyperglycemia. Generally, diabetes mellitus is refers to the sweet. That is, diabetes mellitus is due to deficiency of the insulin. So the point to remember that insulin is for the conversion of insulin, reduces the glucose level by executing glycogenesis in the liver, which convert the glucose into glycogen. So glucose levels are decreased. Thereby there is a balance of the glucose, both the action of insulin and the glucagon. But here, as insulin deficiency takes place, so glucose is not converted into what is said to be the glycogen. So glucose level remain increased than the normal. That's what it is, hyperglycemia. And generally, this diabetes mellitus is of two types. That is, insulin dependent diabetes mellitus, and another is said to be the non-insulin diabetes mellitus we see. That is the insulin dependent diabetes mellitus, non-insulin dependent diabetes mellitus. So these are what two types under diabetes mellitus: insulin dependent diabetes mellitus, non-insulin dependent diabetes mellitus. There are two things. One, the insulin deficiency, where the glucagon is the action of the insulin is anti-effect to the glucagon, which means the glucagon convert the glycogen into glucose, whereas anti-effect is the function of the insulin with respect to glucagon. That is, insulin convert the glucose into glycogen. So glucose levels are reduced. So in this connection, the deficiency of insulin, the glucagon conversion does not take place. One point. Second point is the cells failed to take the glucose level. So 2 points. So that's what we studied here. Non-insulin dependent diabetes mellitus, insulin dependent diabetes mellitus. So in this connection, either the glucose is failed to convert it into the glycogen. Second one, glucose uptake by cells failed to take place. That is what studied in insulin dependent diabetes mellitus and non-insulin dependent diabetes mellitus. Next, so as the glucose levels increase, so that results in diabetes mellitus. So glucose more happen to be lost through the urine, and glucose levels increases in the blood, which is reflected in the excessive urination through the glucose. And here the point to remember, in diabetes mellitus 3 polys are observed. 3 polys in the sense of 1, polydipsia. Next, polyphenylketonuria. phagia, polyphagia, and polyuria. Polyuria are what observed. Polydipsia, excessive thirsty, excessive thirsty, excessive thirsty, and polyphagia, excessive eating. Phagia in the sense the eating, and polyuria, excessive urination. Excessive urination is observed in this connection. So three polys, polydipsia, polyphagia, polyuria are observed. Besides that, we do observe that the fat, one point to remember here, the glucose levels increase and carbohydrate. So carbohydrate metabolism, glucose are increased such that fat degradation also takes place. So fat degradation results in the accumulation of the ketone bodies. There are two indicatives in diabetes mellitus. One, glycosuria, we do learned earlier. Under the excretory disorders, we discussed the glycosuria and ketonuria. Ketonuria are the two conditions. The diabetes mellitus is indicated by ketonuria and glycosuria. Glycosuria, ketonuria are the indicatives of the diabetes mellitus. Now, the excessive glucose levels is glycosuria and ketonuria. That is degradation of the fat results in the cholesterol and ketone bodies. Ketone bodies increased. Ketones are the acidic and poisonous whose levels are increased. That's what it is, ketonuria. That's the reason why glycosuria and ketonuria are the indicatives of the diabetes mellitus, where the symptoms are observed. That is excessive thirsty, excessive hunger, and excessive urination. Dehydration takes place. That is all what due to increasing in the glucose level. That's what it is, hyperglycemia. So that's what the diabetes mellitus, characterized by three polys. And if the IDDM and NIDDM, this is insulin dependent diabetes mellitus. This is non-insulin dependent diabetes mellitus. Basically, this insulin dependent diabetes mellitus is named to be the juvenile diabetes mellitus, whereas this is said to be the age onset type 1 and type 2. Type 1 and type 2 are what we see. Let's see the differences between these two. That is IDDM. What happened to be takes place in the 0 year, that is a newborn baby to till 20 years, that is before 20 years it happens to be takes place. The individual with the before 20 years or happen to be takes place insulin dependent diabetes mellitus, that's what juvenile or else type 1. And here this is taking place in the individual more aged, that is more than 30 years and above. 30 years and above individuals. Next, this is IDDM where they require the insulin injection. Insulin injection is compulsory. Daily insulin injection. Injection is compulsory for them. Whereas here insulin injection is not required. Insulin induction is not required. Not required. That's the reason why non-insulin dependent diabetes mellitus, whereas they require. And apart from that, the regular exercise, meditation can cure the non-insulin dependent diabetes mellitus. But insulin dependent diabetes mellitus, regular exercise and regular diet cannot control. Next, here what we see is the individuals are, if we observe normal weight here, this is the individual happen to be with normal weight, but here the obesity, the individual obese in the sense obesity, excessive the weight individuals are non-insulin dependent diabetes mellitus. And ketones are increased here more, whereas here normal. This is what we see, IDDM and non-insulin NIDDM. This is juvenile diabetes mellitus. This is age onset. That is in old people. That is as one become older and older. This is happen to be takes place, which is a normal condition. That's the reason as the age progresses, the metabolism decreases, which reflected as the age onset. This can be overcome by the regular exercise, medication, and meditation can avoid this, but this is doesn't be overcome with the meditation and exercise. This is takes place in the individual from 0 year to 20 years of age. That is at early age it attacks. So it is juvenile, whereas this is in the aged individuals. Next, insulin injection is compulsory here. Insulin injection is not compulsory. And these are with normal weight, whereas these are with obesity. This is what we do discuss in the case of the hyperglycemia, diabetes mellitus. And even certain times hypoglycemia, the other conditions we observe are said to be the hypoglycemia. Hypoglycemia in the sense, hypoglycemia is what also studied as hypoglycemia. Hypoglycemia. Hypo means reduced glucose level. It can be also said to be the hyperinsulinism, which means as the hypoglycemia is caused in the individual who takes excessive insulin injection, excessive insulin intake, or else those who are taking the insulin injection if taken excessively. What is the role played by the insulin? Insulin is for the converting the glucose into glycogen. If it is taken excessively, all the glucose is converted into glycogen. So, as glucose deficiency takes place, that's what it is, hypoglycemia. There are two reasons for it. One, the deficiency of glucagon. What is the role played by glucagon? Glucagon is a hyperglycemic, which converts the glycogen into glucose. So, the glucagon deficiency of glucagon, which is done by the glucagon is secreted by the alpha cells. Is it right? So, the alpha cells failed to absence or else absence of glucagon. As glucagon is absent, the glucose is failed to, the glycogen is failed to form the glucose. So glycogen levels remain as it is. Here the point to remember is in the liver, the action of the alpha cells secreting the glucagon, glucagon converts the glycogen into glucose, so increases the glucose levels. So here deficiency of alpha cells failed to secrete the glucagon, so glycogen failed to convert into glucose, so glucose levels decrease. That's what hypoglycemia. Second point to remember is insulin deficiency. Insulin is excessively secreted. Insulin is excessively secreted, which means the tumors in the beta cells, or else the pancreas. Tumors in pancreas excessively secretes insulin. So the tumors in the pancreas excessively secretes the insulin such that the more glucose converted into glycogen, and it is not available for even one point to remember that glucose is the only nutrient that the brain takes. So insulin is excessively secreted such that glucose is failed to converted in glucose is excessively converted into the glycogen. So glucose availability does not exist. So that's what it is taking to the insulin shock. Thank you.